Hello everyone, welcome back. We will cover the heap tree in a data structure topic in this video. We will understand what is heap tree and then understand the real life use case around it and also understand how it is represented using array. We will also discuss the topic which we will cover in the next video. So let's start. What is heap tree? Heap tree is a special type of binary tree. We know that binary tree is nothing but that each node can have maximum two child nodes, like left and right. So heap tree is a type of binary tree only, but it has a special properties. So it satisfies two special properties. First is shape. So in heap tree, the shape of the tree is complete binary tree. So when we say complete binary tree, it means that each level starting from level 0 has the nodes and any new node or any new element is added at the last level of the tree. So above levels will always have the nodes. So that is called as a complete binary tree. And the shape of the heap tree is always complete binary tree. The second property is very important. And that is why it is called as heap tree. The second property is a heap, which is basically the specific ordering between the parent and child nodes. So how these parent and child nodes are related, that heap property we will discuss. So there are two types of heap trees depending on the heap property. So the first type of heap tree is max heap. So the heap property in the max heap tree is that each parent node value is greater than or equal to its child nodes. So you can see in this tree that each parent node has a value greater than or equal to its child nodes. And it is true for each parent node. So that is how the heap property is maintained here. It is called as a max heap tree. In this case, the root always contains the largest value. The second type of heap tree is minimum heap or min heap, where each parent node value is less than or equal to its child nodes. And root contains the smallest value in this case. So the example of min heap tree is this. You can see each parent node has a value less than or equal to its child nodes. So this is called as a heap property, which is specific ordering between the parent and child nodes. And based on that heap property, there are two types of heap trees, max heap and min heap. The heap tree is typically implemented using array. We will understand the array representation of heap tree soon. Now we understood what is heap tree, but why do we need a heap tree? So let's understand the real life use case of heap tree. Let's say you have a mobile phone where we generally with mobile phone, we try to do multitasking, right? We basically play music. While playing the music, we download some file. Then we also open the social media feed, refresh it, etc. So there are multiple tasks we can do on a mobile. And each task let's say, have some priority. So higher the priority, the important that task is. So the task running and managed by mobile operating system, CPU, based on the priority. High priority task given the time first, right? Because the CPU of operating system cannot perform all the tasks at all time, right? If there are 10 tasks, CPU will have its own capacity. It can run only 3 tasks at a time parallelly. So it has to basically make sure that each task gets the time. So depending on the priority of the task, CPU adjusted the time and gives the time to the high priority task first. So let's say there are 3 tasks happening, like music, downloading file, and media feed refresh. Refresh is lowest priority and playing music is highest priority. Now, if I represent this task in a heap tree based on the priority value, let's say max heap tree, you can see music comes at the top and download and feed refresh are coming as a child of the music. So the high priority task is at the top. Now let's say you get a call. Now, whenever we get a call, we know that everything stops in a mobile, right? like music stops or some other things which we are doing stops. So call is given a highest priority. So when that happens, CPU adjusted the heap tree and gives the call task priority first or the time first. So CPU adjusted the execution based on the priority of the task because call has a high priority. And as soon as the call is finished, when we cut the call, then suddenly music starts playing. So CPU makes sure that each task gets a time and the high priority task is given time first. So you can see this is done by CPU using max heap data structure, right? So this is how the real life use case can connect to the heap tree data structure. And there are multiple cases where you will need ordering based on the priority, either it is low priority first or high priority first. So this is how heap tree can be used in a real life use cases. Now let's understand the array representation of heap tree. We saw this heap tree in the previous slides. So heap tree is typically implemented using array. So in an array, it looks like this. And these are the indices of the array. So root is always at the 0th index. So for node or parent at index I, which is 0, let's say, the left child is present at 2 into I plus 1. And right child is present at 2 into I plus 2. Let's understand this. Let's say for node at I equal to 0, which is 9. The left child of 9 is 7. It will be present at 2 into I. I is 0. 2 into 0 plus 1 is 1. So you can see 7 is present at the index 1. And similarly, the right child of 9, based on this formula, it is present at index 2. Right child of 9 is 8. It is present at index 2. So based on the index of node, the left child and right child will be present at this respective index. So left child will always be present at a odd number index and right child is always present at a even number index. So let's say if we add 4 here and new element is always added at the end of the array. So the index of 4 in a array is 6. So it will basically, if I say 6, it will like, if I want to see whose right child it is, because 6 is even. So 2 into I plus 2 is equal to 6. 2 goes here. 6 minus 2 is 4. 4 divided by 2 is 2. So I equal to 2. So I equal to 2 means 8. So it became a right child of 8. Now, sometimes if you see here, it is still a max heap tree. So it has property of complete binary and it is still satisfying the heap property of the heap tree. That is a max heap tree, right? Where each node value is greater than or equal to its child node's value. But it is possible that we might insert such node like this. Let's say if we insert a 10 and it is at index 7. So index 7 is odd, so it is a left child. Left child of what? 2 into I plus 1 equal to 7. 7 minus 1, 6. 6 divided by 2, 3. I equal to 3. So it is at index 3 is 3. So it is a left child of 3. Now if we see the heap property of heap tree is not satisfied now because 3 is not greater than 10. So the max heap property is not satisfied. So it is possible that whenever we add a new element to the heap tree, the heap property of the heap tree can get violated. So after insertion or a deletion, the heap property, max or min, can become false. So to maintain that property, now after insertion or deletion, to maintain that property, a specific operation is performed after every insertion or deletion. That specific operation is called as a Heapify. So what is meant by Heapify? So it is kind of a specific operation which is performed whenever after every insertion or deletion, we see that heap property is not getting satisfied. So how this Heapify operation works, what is the time complexity of this Heapify operation during insertion and deletion, we will understand this in a detail in our next video. So I hope you understood about the heap tree data structure concept and how we can relate to it with some real life use case and the array representation of heap tree, how it is typically implemented using array. So if you like the video, please share and subscribe. Thank you so much.